Baking soda and vinegar.
And vinegar, right? And how are we going to mix them? Do you guys remember?
With a balloon and a water bottle.
A balloon and a flask. Okay, an Erlenmeyer flask.
It's a 2-to-1 ratio.
The flask is going to shape like this, right? It's called an Erlenmeyer flask, and we shape a little like that.
My sister didn't want to come.
The balloon, right, is going to have in it,
Baking soda.
right, baking soda, and then we're going to put it over
Vinegar.
here. Now, it's not exactly baking soda. So baking soda is sodium bicarbonate, and what I'm going to have is sodium carbonate. Okay, it's almost exactly the same, but it's sodium carbonate. So I'm going to put
What does
the
bi mean?
bicarbonate refers to the differences are here's sodium bicarbonate and here's sodium carbonate. Okay, whoops, Na2CO3. So these are the differences here. This one has a hydrogen, one hydrogen here, whereas this one has, instead of one sodium and one hydrogen, has 2 sodiums. Okay? Vinegar is an acid. Sodium carbonate acts like a base. The carbonate ion takes these protons away. Hydrogen ions.
Which one are we using?
So we're going to use this
Na2CO3?
one here because it gives us a little more kick. Okay? So, and as I just heard somebody say, that the ratio of the HC2H3O2 and the Na2CO3, correct, is 2 to 1. 2 to 1, right? Okay, so we're getting close to doing that. Now,
Are you doing that?
no, we can't do that today yet because of one thing. Let me show you.
The vinegar is a dissolved form of H2O.
Right.
That change it, and I'm guessing the water bounds change it.
This is vinegar, right? Vinegar, or let's see, does it say any more besides that right there? Somebody come up here really quick. Go on up, read this right here. What's this say? Acidic. 5%. So this is only 5% acetic acid
So it's 95% water, most of it.
and 95% water. And that's why, you can drink it. It doesn't taste good. Probably not a good idea, but you can drink it, right?
There was.
What special person did they give vinegar to?
Colin.
To drink. Colin.
He drinks vinegar and water all the
Oh.
time.
What other special person did
No,
they drink?
Charles.
No, I don't.
Dead
They gave
people?
it to Jesus when he was on the cross, remember?
Oh, yeah.
He was thirsty and they gave him some vinegar. All right,
I don't
so
think they wanted it.
we have the vinegar there, but the vinegar is only 5%.
We gotta go get 100%
5%.
acid.
100% is too dangerous to work with here in the house.
What if you go to your lab?
Or if you work in the lab, you have to work in the hood with strong acid. You can't work on the countertop because they smell really strong and they can burn you very easily. All right? So, we have to do some calculations to identify how much of that stuff we should mix. Because if I take, how many grams?
It would actually be 2 to 1.
We've done lots of problems. We've done lots of problems where we said, for example, if I take 10 grams of Na2CO3, how many grams of HC2H3O2 do I need, right? We've done this type of problem. And this type of problem is solved by, what's the first step?
Putting the
Equal sign
then the unit,
and a line.
and the line, then the
Start with,
units. You did it, we
Unit.
how many grams what am I looking for?
Grams of HC2H3O2.
Grams of HC2H3O2, right? Starting with
10 grams of
10 grams of Na2CO3, right?
Then
And then I can go to the land of the moles by converting grams of Na2CO3 to moles of Na2CO3.
106 grams.
106 grams for every 1 mole, and then I can go from moles of Na2CO3 to moles of HC2H3O2. That's a 2 to 1 ratio, right?
But then we need to go back to grams.
Then we go back to grams. So this is moles of this. So we go moles of HC2, H3O2, grams of HC2. You guys got it, right? We've done that before. However, if in the end we say that's how many grams of this stuff we need, but then we see that this is only what?
5%.
5%. We have to figure out how much of that stuff we need to add. That is a pain in the neck.
We gotta
Because,
divide.
what's that?
Wouldn't we have to divide NaPCO2?
That's how many grams we would need, but we would also need to multiply it by, we would need, this is only 5%, right? So we would need to multiply it by 95 to get enough, so we had the right amount.
Wouldn't it be 20?
20? Oh, yeah. So, but,
Add that.
okay, right. But, when you're talking about how much stuff there is, in this case it's acetic acid in the water, right?
Volume.
5%, what does 5% mean? You guys know?
1/20.
What's that? A 20th, but what does that mean in terms of, is that 5 moles of vinegar for every 100 moles of stuff? 5% means per 100, right?
Yeah. And a mole's not 100.
Not
Moles,
moles.
not 100. What is it then? Is it 5 grams of vinegar for every 100 grams of solution?
Yeah.
Yes.
Is it?
Well, it's kind of a weight for weight or weight for volume.
Yeah. What it is another, what?
That's more.
Pain in the neck.
Another pain in the neck. That's right. The easiest way to get around this, in my opinion at least, is to express the concentration of vinegar and how many moles of vinegar I have. Because if I have the number of moles of vinegar in that container, then I can stay in the land of moles and fix my problem while I'm there. Does that make sense?
Yeah.
So I'm going to introduce to you a new word. It's very similar to the previous word that I was introduced to, or that I introduced you to. Mole.
Molar.
You guys say molar?
Molar.
Molar.
I have some others.
If you go to the dentist, they'll pull out a
Molar.
I have a
molar.
molar.
That's
It
right.
seems like there's less people than usual. No, I haven't.
Yeah, it's a Monday, I think. People forgot. Tired.
A lot of people left.
A lot of people left.
Oh yeah, I'm leaving today.
Really?
Yeah, they are. They are.
All right.
Oh yeah.
Molar.
Jacob's
You're
done.
missing it.
Means.
Oh, man.
Molar means. Here's what molar means. I'll show you what molar means.
You can watch it.
It means moles of stuff like acetic acid for every
100.
liter
Oh.
of the whole mix, of the solution.
Ooh.
Now you have more units to work with.
Yeah, now you can use that for that because
That's right. And
it's
so now you can know
5%
what
for liter solution.
how many moles or how many milliliters of that or how many liters of that you need to get 1 mole. Does that make sense?
Isn't that way more than 1 mole?
In there? No, it's a lot less.
Because it's telling you the total amount of
Okay,
that
so,
element, not of
The new word, the word of the day is molar, which means moles per liter. Can you say moles per liter?
Moles per liter. Hey, that's a great.
Moles of the chemical per liter of the solution. Now what's the rest of the stuff?
water.
Water.
All
That's
water.
right. The rest of the stuff is water. Does that make
Or
sense?
apple juice.
What?
Or apple juice.
No. It's water. I mean, you mean like because it's apple cider vinegar, you mean?
Yeah.
Yeah, well, yeah. But in general, in a solution, when you're making a solution, we think of moles of that specific chemical dissolved in water. Now, it's not always water. That's right. But for us, in most of the scenarios, you
Are we
use
going
water.
to use just normal vinegar, distilled vinegar?
We are. We're just going to use regular vinegar. We're not going to use apple cider. That's all I have right now. Okay, so molar. Moles
Moles
of
per
stuff.
liter.
per liter of solution. Okay, so now let's do a question like this. If I put 10 grams of vinegar, HC2H3O2, into 1 liter of water,
How many moles do I get?
what is the, now molarity, molarity, right? Molarity is describing how many mole, or what the molarity is, talking about the how molar the
Is it
solution
talking
is,
about
right?
malaria?
No. And it's represented or shown by a big M, abbreviated by a big M. So this is the kind of problem that we want to be able to solve now. Can somebody read this problem for me, David? Can you read it for me? You don't know how to read?
I know how to read. I can.
No, David will read it.
I'll read it. I read it too.
Not very good handwriting. Grams. HC2H3O2.
Can I show you?
1 liter of, that's a water. What is the, what's big M mean? Molarity of the solution. You guys got it?
Yes.
All right, can we answer it?
It's hard.
What do we do to answer the question?
10 grams for HC2H3.
Equal sign,
Breathe
breathe out, draw a line. What are we looking for over here?
Units.
of HC2O, what?
Molar.
Molarity.
Molarity of
This is what they gave
HC2H3O2.
us. But here we're supposed to put what we're looking for.
Mol-
It's big M.
molarity
What does
of-
big M stand for?
Molarity.
Molarity. And what is molarity?
Moles per liter.
Liter.
So I'm going to put that over here. Moles per liter. All right?
Why do we want to figure moles per liter?
Because we would like to know how many moles of our chemical of interest is in the solution, so that we know how to mix them appropriately when it comes time to
So we could do liters, not saying, oh, I want a mole of this.
That's right, because we don't know what a mole is. If I want 1 mole of vinegar, how much of that stuff do I have to add? Right? Okay, so this is moles of what? HC2H3O2, correct?
Yes.
Yes.
So what do I start with over here?
10 grams of it.
All right, 10 grams. HC2H3O2.
Then moles.
And now I'm going to convert those grams into what?
Moles.
Moles. So I'm going to go from grams of HC2H3O2. What goes up here? What goes up here?
Moles.
Moles. Sit down, Brady. You're distracting him. HC2H3O2.
But when are we going to put malaria so we can get malaria?
Well, if we stop right here, and what numbers do we have? Does anybody remember how many grams there were per mole of that stuff?
106.
That was the other
Oh,
stuff.
no, we get moles.
Was it
6,000.
12 times 2?
60.
24 was it 60?
Yeah.
Yeah, 60.
60 grams for every 1 mole. Okay? So if we stop now, what units are we in? If we stop now,
Moles.
we're in moles. What do we want to be in?
No, molecular.
We want to be in molarity, which is moles per liter. Well, how many liters of water does it say we have? Or how many
1.
liters do we have in solution? 1. So I can put here
1 liter.
1 liter.
But don't we have to cancel out the moles?
Nope, we want moles in the end, see? We want moles, and we want moles to be over what? Liters. And so that's all we have to do. Now
10
we take
times
10
1 is 10.
divided by 60.
What's 10 divided by 60?
That's 0.6. 10 divided by 60 is
0.6.
60 divided by 10. 10 divided by 60 is 0.6.
10 divided by 60 is 0.6. It actually means
Put it in your calculator, young man.
0.166666.
0.166666.
Yeah,
Is that right?
10 divided
Somebody else do it. Make sure. 10 divided by 60. 6 divided by 10 is 0.6. Okay. All right. So 0.17 basically, right?
Yeah.
All right. And now what is that? What is that we found there?
How many molars?
How many moles of stuff there are for every what?
Liter. 1 liter of
Liter
water.
of that given solution.
Times.
Congratulations, everybody. You've been introduced to
Molar.
molarity. The first time in your whole life you've heard of molarity, right? Congratulations. We're getting really close now because after we know how many moles for every liter, then we can figure out how, if I have this many grams of this stuff, how many moles, or how many liters of the solution, which is a given molarity. Right? All right. Way to go, guys. See ya tomorrow.